Hello students, welcome back. Students, in previous lecture we had a discussion about properties of solids. So a few properties we have already discussed. Now the next property of a salt is water of crystallization. So students, when we prepare crystals of say a salt, a certain quantity of water is retained by the crystal of the salt, and that quantity of water is called water of crystallization. So what is water of crystallization, students? A definite amount of water which is retained by the crystal of a salt is called water of crystallization. For example, students, when copper sulfate salt is crystallized, each crystal retains 5 water molecules and we get this hydrated salt. So this hydrated salt we all know is called blue vitriol. And students, in blue vitriol, this quantity of water, that is 5 water molecules, this is called water of crystallization. This is called water of crystallization. So we can say that this blue vitriol is copper sulfate pentahydrate. So we have many other examples, students, like sodium carbonate crystals are decahydrated and we call this washing soda. Then sodium sulfate crystals are also decahydrate. So sodium sulfate decahydrate. This is called Glober's salt. Glober's salt. So this is Glober's salt. Then we have say magnesium sulfate, which is heptahydrate. So there are 7 water molecules as water of crystallization. Now this is called Epsom salt. Then we have calcium sulfate .2H2O. This is called gypsum. So there are many salts, like we have learned this earlier, that zinc sulfate crystals, which is called white vitriol. They have 7 water molecules as water of crystallization. Then we have ferrous sulfate crystals. They also have what? This is green vitriol, 7 water molecules of crystallization. So students, many salts, when they undergo crystallization, they retain a certain quantity of water, which is called water of crystallization. Now students, please note this point, that this quantity of water is always in loose combination with the ions of the salt. So since the water of crystallization is in loose combination, it can be easily removed by heating. For example, when we heat copper sulfate crystals, which are blue in color, so this is blue vitriol. Students, when we heat this, say above 100 degrees Celsius, what happens is that this quantity of water is removed. The 5 water molecules, they are removed, and we get anhydrous copper sulfate, which is white in color, And students, due to this process, the substance which otherwise is crystalline becomes powdery or amorphous. Now students, let me tell you, when we carry out this reaction in a dry test tube, these water droplets, they appear near the top of the test tube as condensed water molecules. So student, this was water of crystallization. Now another important point, students, some salts do not have water of crystallization. Means there are many salts like rock salt NaCl, then we have nitrates like KNO3, NaNO3, then we have ammonium chloride, etc. Now students, these salts, upon crystallization do not retain any quantity of water. So these salts always exist in anhydrous state. Now students, please listen carefully. When we heat these salts in a dry test tube, a crackling sound is produced because of breaking down of bigger crystals into smaller ones, and this phenomena is called decrapitation. Decrapitation. So what is decrapitation? It is a process due to which certain salts produce crackling sound on heating, and this is because of breaking up of bigger crystals into smaller ones. So students, now we'll move on to the next property of salts, which is called efflorescence. So students, first we will understand what is efflorescence. So students, what happens in efflorescence is that when we expose some crystals or some salts to, say, atmospheric air, they lose water of crystallization either completely or partly. So students, this property of some salts to lose water of crystallization from crystals either completely or partly when they are exposed to the atmosphere is called efflorescence. For example, students, say I have sodium carbonate, decahydrate crystal. Now student, when this is called washing soda, when we expose washing soda to air, and remember air should be dry, then what happens is that this sodium carbonate loses water of crystallization, but not completely. Only 9 water molecules of crystallization are they are lost. So this is called efflorescence. But some salts, they lose water of crystallization completely also, like Glober's salt, which is also decahydrate. Now, when exposed to dry air, loses its water of crystallization completely. पूरी तरह से जितना भी उसका water of crystallization है वो lose कर देगा to the atmospheric air. So students, this process or this property by virtue of which some salts lose their water of crystallization either partly or completely on exposure to dry air is called efflorescence. And students, such salts or such compounds are called efflorescent compounds. Efflorescent compounds. Now, another important thing about this efflorescence is that before efflorescence, these substances are crystalline in nature. That means they have a definite geometry. But upon efflorescence, they become amorphous. Amorphous means they do not have any characteristic shape. So they become amorphous. So this is very, very important, that due to efflorescence, crystalline substances become amorphous. Now students, what is the essential condition for efflorescence? So students, listen carefully. Efflorescence occurs when the salt has a greater vapor pressure than the vapor pressure of atmosphere. So what happens is that since salt has a greater vapor pressure, it will lose water to the dry air. और कब तक lose करेगा? Until an equilibrium is established. Means जब तक कि air और salt का vapor pressure equal नहीं हो जाता. So that means the essential condition for efflorescence is that air should be dry so that salt loses water to the air until an equilibrium is attained. So which means that efflorescence is maximized in dry conditions. जब air dry होगा तभी salt water lose करेगा to the air. But it is minimized in humid air. Means जब air में water vapor बहुत होगा तब आपका efflorescence नहीं होगा या बहुत कम होगा. So students, this was efflorescence. Now we will discuss the next property, which is called hygroscopy. Students, we have another important property of salts which is called hygroscopy. Now student, what happens in hygroscopy? Actually जब हम कुछ salts को atmosphere में expose करते हैं, even for a short time, then what happens is that some compounds or some salts have a tendency to absorb moisture or have a tendency to absorb water vapor from the air, but they do not dissolve in the absorbed water. So students, this property of some salts to absorb moisture, that is water vapor, from the air when the salt is exposed to the atmosphere even for a short time is called hygroscopy, and such substances are called hygroscopic substances. Now I have some examples of hygroscopic substances. For example, students, concentrated H2SO4 is a hygroscopic substance as it can absorb moisture from the air. Then we have phosphorus pentoxide, which is also hygroscopic substance. Then we have quicklime, which is called calcium oxide. Then we have silica gel. Now silica gel is also a hygroscopic substance. So all these substances have property to absorb moisture from the air, and this property is called hygroscopy, and these substances are called hygroscopic substances. Now students, what is the essential condition for hygroscopy? So students, only those compounds undergo hygroscopy, means they show this nature, which have greater affinity for water, or we can say that hygroscopy occurs only when the air has greater moisture content. That means air has greater vapor pressure than the salt. So students, this property is very useful in drying of gases. All these substances like concentrated H2SO4, P2O5, calcium oxide, silica gel, they are very good drying agents. And why they are used as drying agents? Because they are hygroscopic. ये सब substances किसी दूसरे substance से moisture को absorb कर लेंगे because of great affinity for water, and thus these substances, all hygroscopic substances, are very good drying agents. Now students, we will discuss another similar property of some substances which is called delicescence. Dear students, what is delicescence? Listen carefully. Some salts or some compounds, when exposed to the air, that is to the atmospheric air, absorb moisture from the air and become wet, and ultimately they dissolve in the absorbed water to form a saturated solution. Now, so this property of some compounds or salts to absorb water and then to dissolve in the absorbed water to form a saturated solution is called delicescence, and such substances are therefore called delicescent substances. The common examples of delicescent substances we have is sodium hydroxide, then we have potassium hydroxide, then calcium chloride, magnesium chloride, then we have nitrates, zinc nitrate, copper nitrate, etc. So students, all these substances are delicescent, which means ये सभी substances को जैसे ही आप expose करोगे, say under ordinary condition to the atmosphere, they absorb moisture from the air and ultimately they dissolve in the moisture absorbed to form a saturated solution. That means they become moist. So students, now what is the essential condition for delicescence? Means salt moisture absorb कब करेगा? Obvious है students, when the vapor pressure of the water in the salt is less than the vapor pressure in the atmosphere, then salt will absorb water from the air until an equilibrium is attained. So this means delicescence is maximized when the air has greater water content That means air जब humid होगा, means humidity जब air में बहुत ज़्यादा होगी, delicescence is maximized. Now students, there is a basic difference between delicescence and hygroscopic. Now, what is hygroscopy? In hygroscopy also substances, they absorb moisture from the air, but they do not dissolve in it. But in delicescence, these substances absorb water vapor from the air and ultimately dissolve in it. So this was very important to note, that for delicescence, air should be humid, means there should be a large content, water content in the air. Now students, let me tell you that our table salt, that is NaCl, is non-hygroscopic and non-delicescent compound, means ये moisture absorb नहीं करता है. But students, what we observe in rainy season is that the table salt becomes wet. Rainy season में table salt थोड़ा wet हो जाता है. So students, क्यों wet हो गया? Because NaCl तो hygroscopic नहीं है, या NaCl तो delicescent नहीं है. So NaCl itself does not absorb moisture. But students, in rainy season, table salt becomes wet. It is due to the fact that the commercially available sample of NaCl, which we use as, say, cooking salt, contains impurities of calcium chloride and magnesium chloride. And these two salts are what? These two salts are, see, they are delicescent. So they absorb moisture. NaCl does not absorb moisture. So इसका मतलब rainy season में अगर common salt wet हो जाता है, it is not due to the fact that NaCl absorbs moisture, but the impurities present in the common salt, they absorb moisture from the air. So this is the reason that table salt becomes wet in dry season. Now students, the next property of the salt or the next type of substances are drying agents and dehydrating agents. Students, before we discuss what are drying agent and what are dehydrating agent, let me share very important thing, that when efflorescence occurs, salts, they lose water to the air. That means salts lose weight. And when students, hygroscopy or delicescence is observed, salts absorb water from the air. That means they gain weight. So remember this point students, in efflorescence, salts lose weight. But in hygroscopy and delicescence, salts gain weight. So this was very, very important. Now students, will move on to the next type of compounds or substances. So first we have drying agents. Now what are drying agents? So students, the substances which remove moisture from the other substances are called drying agents, or these are also called desiccants. These are also called desiccants or desiccating agents. These are also called desiccating agents. So any substance which can remove moisture from the other substances is called a drying agent. Now students, what type of substances can act as drying agents? So let me tell you, hygroscopic substances are very good drying agents, because जो water absorb करेगा किसी दूसरे substance से, वो तो hygroscopic होता है. So that substance can be used as drying agent. That means substances like concentrated H2SO4, then calcium oxide, then we have P2O5, then we have silica gel. All these are drying agents, and इनका main use कहाँ है? In the drying of gases. Like gases like chlorine. Generally, when we prepare chlorine, it has a certain water content also. Means वो moist होता है. तो इसको अगर dry करना है, तो we pass that chlorine through concentrated H2SO4. Similarly, when ammonia gas is prepared in lab, it is also moist. So in order to remove moisture from ammonia, it is dried by this calcium oxide. Similarly, gases like HCl gas can also be dried by these what? Drying agents. Now students, we'll discuss dehydrating agents. What are dehydrating agents? Now, dehydrating agents are those substances which remove either the water of crystallization from hydrated salts, or they remove chemically combined elements of water from other substances. So dehydrating agents भी water निकालेंगे, but they remove which water? They remove the chemically combined elements of water, or they remove water of crystallization from other compounds. For example, students, blue vitriol has some water molecules which are in loose chemical combination. So when we drop few drops of concentrated H2SO4 on blue vitriol crystals, what happens? All the water will be absorbed by concentrated H2SO4. So water को ये absorb कर लेगा, and we get this white anhydrous copper sulfate. So here we are using what? Copper concentrated H2SO4 as dehydrating agent. We have another example, students. I have ethanol. Now this ethanol is an alcohol, but when we heat ethanol with say concentrated H2SO4, now students, as such इसमें water नहीं है, but there are elements of water. So H and OH, they are removed by concentrated H2SO4, and we get ethene C2H4. Then students, I have another example of formic acid. Now students, one formic acid is heated with H2SO4. As such, there is no water, but there are elements of water which are removed by concentrated H2SO4, and thus we prepare carbon monoxide. So similarly, students, we have many examples. One important example is of sugar. Now, when we drop concentrated H2SO4 on sugar crystals, all the water वैसे है नहीं, but there are elements of water in this compound, so these are removed, and we are left with this, which is called sugar charcoal. This is called sugar charcoal. So in all these examples, the concentrated sulfuric acid is what? Removing elements of water from the compounds, and that is why we say concentrated H2SO4 is a dehydrating agent. So students, there is a basic difference between a drying agent and dehydrating agent. A drying agent removes the already available moisture from the compounds or substances, whereas a dehydrating agent removes chemically combined elements of water from the other substances. And then there is another basic difference, then that action of a drying agent is just a physical change. सिर्फ जो चीज moist है उसको वो dry कर देता है, but action of a dehydrating agent produces new compounds. So students, this was our last topic of this unit. So we have now completed unit 3. So students, that is all for today. Thank you.